Hi there, I'm Charlie Wu and I'm here with Chen, my old classmate. Together we will be discussing some opinions to the causes of Mpemba effect. While this video's contents have not been proven, it will explain the thought process behind some of our ideas.
We find that the freezing process doesn't comply with people's awareness. That is, the temperature of water was decreased to the freezing point. Then the water molecule forms crystal structure. After the water is completely freezed, the temperature of the ice continues to decline. Why this model doesn't make sense?
If you observe freezing water, you will find that the freezing process is not occurred in anywhere. It always starts from the outer part to the center. This shows that the ice formation and the external cold source are inextricably linked. And based on the perspective of molecules' kinetic energy distribution, it is impossible that all water molecules are at freeze point. They must be at different energy levels. Therefore, as long as a part of the water molecules is in particular state, the freezing process is able to occur.
In addition, we find that there have been many hypotheses on the internet and trying to explain the Mpemba effect, including evaporation, solubility difference, law of cooling, and so on. But all of them are still not able to satisfy everyone. The mystery of the Mpemba effect is yet to be unlocked. What are the details of this point of view?
We don't intend to discuss the evaporation and solubility, since their effects are too small to make the Mpemba effect obviously. Then we are discussing the law of cooling hypothesis, which is now generally recognized. This theory is based on Newton's law of cooling, which shows that the cooling rate of an object is proportional to the gap of temperature between the object and the environment. However, there is also a blind spot in this hypothesis. That is, if this hypothesis is true, the hot water only catch up with cold water's cooling state at most. What causes hot water to go beyond the cold water, forming a colder and faster freezing process? By the way, using an equation without considering phase change to explain the properties of it, this idea is really strange, isn't it?
At the last part of this video, let's talk about the new model we established that's based on collision theory and chemical equilibrium. If the hypothesis let the entire water cools down together, and then begin to freeze its warm. How about consider it as an onion with numerous thin layers and each layer freeze alone. In each tiny point, the water molecule collide cold surface, losing their kinetic energy and stay on it. Then, the ice layer is formed. Does this model have any advantage to explain the Mpemba effect?
If you remember the common collision model in chemistry and physics, it's not difficult to imagine that the water molecules in the freezing process are at different energy levels. If the cold surface is so cold that most of the water molecules lose their energy and form lattice when they collide on it, we say that a reaction is tending to form ice. But the reaction equilibrium and the reaction rate are two independent things. Therefore, though the hot water is not so tending to form ice, the frequency of its collision is much higher than the cool water. This fact causes the freezing rate of hot water is faster than cool one. Another common example used to explain the independence between reaction equilibrium and reaction rate is Haber process. Even though the reaction of synthetic ammonia at low temperatures will tend to form the product, we always heat the raw material to 500 degrees rather than let the reaction carry out at low temperature.